Alright, so today we are going to answer the question of when will I ever use this? Yay! Okay. But first, we've been talking about differential equation. So today we're going to look at one that requires a little bit different steps.
That looks terrifying.
It's not as bad as you think. What is different about this one, besides that there's a lot, than some of the other stuff that we've dealt with? Everything's on one side, so it's set equal to 0. Okay. What else?
Lots of x's and lots
Yeah,
of y's.
so what was that saying?
It's not like dy over dx, they're separate.
Correct. So most of the time we've had dy over dx and we've had to multiply the dx. This time they're already separated for us. Now we still want to group them and do our separation of variables by like moving them to one side. But this time instead of multiplying by the dx, what am I going to have to do? Subtract that over. Okay, so we still want to move it over, but we're going to have to move all of this jazz to the other side to start with. And now from there, we can start like dividing and multiplying as we need to. Because I still need my x's to go with my dx and my y's to go with my dys. Okay, so what from the left side do we need to move to the right side? What?
Yeah, or I guess
The e, okay, yeah. So the e, and how are we going to move that over? Divide it. And then what do we need to move from the right side?
The y.
The y, okay? Which we also have to divide. So we get y squared divided by y times dy, and then x divided by e to the negative x squared. Now, can we simplify any of that?
Yeah.
Yes, how so?
Move the dx squared up.
Is it still negative?
No.
No, now it's positive. Okay, what about the left side?
Can you make it y minus 1 over y?
Yep.
Hooray.
Okay. Now, what can we do? Yeah.
Would the right side be negative?
I was also wondering that.
Yeah.
Since you subtracted the.
Yes.
Okay, that's cool.
There we go. So now what can we do?
Integrate.
Yay! Okay, so if I integrate the left side, what do we get?
Y squared divided by 2 minus the natural 1 of y. Absolute value of y. Plus c.
Yeah, I'm gonna go ahead and put my c on the x side, but yeah. Now, what are we gonna have to do in order to integrate my right side?
U sum.
Okay, what do we want to let our u be?
X squared.
Which means that our du is,
2x.
Yeah.
2 over.
yeah. So we have to,
No,
Divide by 1
so we end up with a negative 1/2 out in the front. And then the antiderivative of e to the u is going to be e to the u, except then we have to plug our u back in, so we get x squared. And then we do have to add our plus c. Okay. Are we done?
No.
No.
No. You gotta
Initial
isolate.
condition.
Okay. What else did we say we're supposed to do?
Isolate the y.
Isolate the y when possible, right? Is it going to be very fun to try and isolate this y?
No.
Not really. So this is not one where you would be expected to isolate the y. However, they do give us an initial condition, so we do have to solve for our c. So we're plugging in 1 for our y values and 0 for our x values.
Lovely. Oh, lovely and nice.
So what is the natural log of 1? 0. What is e to the 0? 1. So what is c?
1.
divided by 2 minus the natural log of the absolute value of y equals negative 1/2 e to the x squared plus 1. And now their answer. Great. So it's just kind of an example of a separation of variables that look a little bit different than some of the other ones that we've done. Yes? Alright. Now let's get into growth and decay models.
Ooh, fun.
What is a model? Besides the pretty people in the magazines.
Look like graph.
Stuff that predicts stuff.
Yeah. So like it's an equation that's going to model a specific type of situation, and we can use it to then predict, okay, what's going to happen in the future. Now, specifically for a growth and decay model, the way that we describe this is we say the rate of change of y is proportional to y. What does that mean? So what is the rate of change of y?
The slope.
dy dx. What does it mean for two things to be proportional?
They have some connection.
If I increase one, then I also have to increase the other, okay? Which means that when I'm setting up an equation, it means that it has to equal the other, which in this case is y. However, the only caveat asterisk is that it could be twicely related or 3 times or something along those lines, which means that there could be some sort of constant k out to the front of it. So it's still directly related, directly proportional, even if I have a constant there. Now, what would it look like if we had said that they were inversely related or inversely proportional? So one increases, one decreases. It's not negative.
1 over?
It would be not 1, but what do we have?
Okay.
K. You would have k over y instead if they were inversely proportional. Okay? Now, if I were to say, take this, and I wanted to solve for the equation that gave me this differential, what would we do? If I want to solve that, what would I do?
Divide by y.
Divide by y
Mm-hmm.
and multiply by dx,
Yep.
and then,
Integrate.
okay, so we get
Natural log absolute value y equals. We got k dx though. That's just a constant. Oh, it's a constant. Yeah.
But let's solve for y. So I would exponentiate
Right.
both sides. E. So we get an e. So we end up with y equals. We're gonna bring down our c and all that stuff. So yes, this should be vaguely familiar. We end up with c equals k x.
That's right.
That's
We did a
an
problem.
exponential thing.
That's exponential.
That's
And it's also when you did exponentials and pre-calc and also
Yes.
too.
radioactive.
Okay, that's good. I thought that was the argument.
Exponential growth.
Not necessarily.
Unless it's negative.
What is negative?
Okay.
So we have a couple of different things that we want to label here. So first off, our C is going to be the initial value. Now that could be like a population value, it could be something else, but it will be our initial
Condition.
value. Okay? Our K value is what we call our constant of proportionality.
Okay.
I don't like that.
Basically, it's the constant that makes it proportional.
But it's so long. There's
If
so many letters.
K is greater than 0, we will have a growth model. And if K is less than 0, we will have a decay model.
What if K equals 0?
Then you don't have an exponential model because this would just be 1 and you'd have a y equals c.
Yeah.
Alright, now the big thing here is that whenever we see like the rate of change and proportional, we need to associate that with this formula. Okay? And basically it saves us the steps of having to solve this differential every single time. Does that make sense? And you could, if you forget what it equals, then you could always just set your differential equation up and solve it. However, that just takes time, so it's easier if we just remember the rate of change is proportional to the original, just means that I have an exponential model.
I hate it so much.
So,
11.
it says the rate of change of y is proportional to y, and when t equals 0, y equals 2, and when t equals 2, y equals 4. What is the value of y when t equals 3? So again, what does that first sentence tell us?
The rate of change of y is proportional to y.
Which means that we're going to use y equals
C.
e to the k t model. T or x, it doesn't matter. A lot of times you'll see t's here instead of x's because we're going to be talking about time. And so you'll see both of those. So in this case, they gave us t's, so we're going to put a t in our model. Now, what's our end goal? What's next to the question mark?
Find when t3.
Find when t is 3. So what would I do?
Well, you find C first.
Yeah, well, our goal is to plug in 3 for t. However, right now we also have a c and a k, so we can't just plug in right now. However, they give us 2 conditions, yes. So if t is 0 and y is 2, what does that give us?
C.
C equals 2.
C equals 2, because that would be our initial value.
Ah.
So we know that c must be 2, so we can go ahead and plug that in. But what are we still needing to find?
K.
K. So what do they give us in order to help us do that?
T and a y value.
Yeah, another set of values. So what do we want to plug in?
T and Y.
Yeah, so we get 4 equals 2 e to the 2k.
Yes.
Yes?
Yes.
So then what do we want to do?
Take the natural log of both sides.
Can't do that yet.
Divide by 2.
So you need to divide by 2. Then we can take the natural log.
Unexponentiated.
Yes. And so we get that k equals 1/2 natural log of 2, or we could also write that as
Yeah.
the natural log of the square root of 2. Okay?
Yes.
So now we're plugging that back in. So we have c is 2, and now we also have that k is the natural log of the square root of t. Okay. Now they just asked us to find the model for this information. That would be our answer. But they asked us to find when t is 3, so we're going to plug that in. So we get 3 natural log of the square root of 2. If this was a non-calculator active question, that would be our answer. Okay, we wouldn't be expected to go anywhere else from there. If it was a calculator active question, then we would plug in to our calculator, and what do we get?
But doesn't the E in natural log
You
actually
could.
cancel, so
What do you mean cancel? It doesn't cancel.
like they reduce, they
Okay,
go away.
so 2 times square root of 2 times 2, so 4 times the square root of 2.
You would have to bring your 3 up if you wanted to do that. So you could have 2 times the square root of 2 cubed. Yeah. But I mean, at the end of the day, I'm plugging all that into my calculator, so.
5.657.
6,
5,
5, 7.
Something like that.
And that would be it.
That puts you less uncomfortable.
Questions on that? Alright. Next one. So it says find the exponential function that passes through those 2 points. So a question like this could be asked one of 2 ways. One, it could just give you the points, or 2, what could it give you instead? A graph where it labels those 2 points. Okay? So either way, we need to still know that we're looking at an exponential. Okay? What's different about the 2 points that they gave us this time instead of the ones that they gave us last time?
You don't know what the initial condition
We don't know what the initial condition is. They don't give us a 1 with 0, so we can't just find C right off the bat. Makes a little bit more work. What do we want to do then?
I have no clue.
Well, let's try plugging those things in, okay? So if I plug in a 1/2 for y, we are also plugging in a 3 for our t value. And the same goes with our other points.
Yeah.
So we get 4k. Yes?
No. Well, yes, but I don't like where this is going.
Okay. So we have 2 variables, 2 equations. So we have a system of equations. So what are our options?
Do stuff with those systems.
What? Do stuff. Okay, what are our 3 options that you have learned to solve systems of equations?
Elimination,
Substitution.
Elimination, substitution, and graphing. Do we want to graph these?
Absolutely
No.
not.
But you could do either substitution or elimination. Most of the time, y'all usually feel more comfortable with substitution, which is fine, okay? If you wanted to do elimination, you could subtract those 2 things and you would get the same thing. So, but if we went about doing substitution, which of our variables is probably going to be a little bit easier to solve for? C. Now, it doesn't matter which equation we use, so which one do we want to use to solve for?
The left one.
The left
Yeah.
one. Sure. So how would I solve for C here?
Divide by e to the 3k.
Okay. Or in other words, I would
Make it down there.
make it on the bottom. So I get 1 divided by 2 times e to the 3k.
Yes.
Then what do I do with that?
Plug it back into the right one.
Plug it into the other one. So that's going to be important. By whichever one you use to solve for, you have to plug it into the other one in order to find the variable. So we get 5 equals 1 divided by 2 e to the 3k times e to the 4k. So then what happens?
Would you like exponents of fact or something?
So I'm dividing. Both things have e's.
Yes.
So we would do 4k minus 3k gives us.
1k.
So I have 1/2 e to the k. So then we would.
What's called that?
Okay, so we get.
And was e to
Natural log of 10.
So k equals
110.
the natural log of 10.
Yes.
So then what do we want to do?
Plug it back in.
Plug it
Find
back
C.
in.
So I get c equals 1 divided by 2 times e to the 3 natural log of 10. Can that be simplified any?
Absolutely.
How so?
You can bring the e and the ln down to make it 10 to the third, right?
So we would bring our 3, so we get 10 to the third. And then my e and my natural log can reduce. What is 10 to the third?
1,000.
So 1/2,000.
Which is also,
A big number.
no, it's actually not. It's actually a small number.
A big looking number.
Okay. What does that look like as a decimal?
Point
A lot.
Point something, something, something five.
I forgot how to do those.
2.
Point 2 and 5.
Yeah, it would be 0.0005.
Do we agree?
No, 'cause that's 5,000. There needs to be another 0 before the 5.
Yes.
Yes.
Point 5, point 0.05, point 0.05, point 0.005, yeah.
Yes. Needs to be
Well, we want it to be right.
Yes. Needs to be 0.00005 is what it needs to be. Because it's 1/1000th, which is 0.001, and then you divide it by 2, which would be 0.0005. That. Yes.
Alright.
I am.
So then what are we doing with those two numbers?
Plugging them back in.
Yes. So we have y equals 0.0005.
0.05. That didn't go away.
That'd be very nice. We have times e to the natural log of 10 times t. Now we do that.
I didn't.
It doesn't ask us to plug in anything, so now it just asks us for the function. So that is the function.
Wait, that's it?
That's it, that's my answer.
That's it?
Hip hip
It
hooray.
feels unfinished.
Well, that's the answer, it's finished. It asks us for the function, y is a function of t, so that's my answer. Well, they could, so like, that would probably be like a part B. So like our part A would probably be like, just find the function. Then part B would be find the tangent line approximation, or find the tangent line at 2, or whatever. So then we would have to take the derivative of that. But in this case, that was all they asked us to do. Alright.
Plutonium, I like plutonium.
Well, plutonium doesn't like you.
Plutonium loves me. What are you talking about?
So, plutonium is a radioactive material that was released at Chernobyl. So it says plutonium has a half-life of 24,000 years. 10 grams of plutonium was released at Chernobyl. How long will it take for 10 grams to decay to 1 gram? A lot of years. So let's find out how many years specifically.
We do a lot of halves.
Yes. So the thing to be careful about this is that a lot of people see the like 24 and 10, okay, and they just want to make it like a straight line between those two things. Does that make sense? So like basically find the slope and then use that as an x and y value. But the relationship between those for half-lives, okay, is an exponential relationship, not a linear relationship. So we are going to use a exponential model. Just specifically, it's a decay model this time instead. So, what is our initial value? 10. So that's nice. We can plug in 10. Okay. Now, what can I plug in to find k?
Well, can we
One
just say that it has
for
to be
Y?
negative?
Well, we're going to need to plug in 1 for y in order to solve for t eventually. But right now, I need to find my k value before I can do that.
T 4,000.
Okay, where do you want to plug the 24,000 into?
No, for Y.
No.
For T.
There we go.
Yes, for t.
Oh,
What do we want to plug in for y?
It's a ton.
5?
Y 5.
Because
Because it's half.
there's
That is
half.
half.
Because it is half. Okay, it's the half-life, so at 24,000 years, we will have half the amount of material that we started with.
Yes.
And now, what can we do?
Solve for K.
Okay, so what do we get?
1/2 equals e to the 24,000 k.
And then this. And then we have to do
This is
natural
natural
log.
logs.
So a natural log of 1/2 equals 24,000 K. And then we have to divide it again. That's a fraction.
Can you just put in
I
the
kind of thought it would be negative.
What is the natural log of 1/2?
I don't know. Is it negative? Is it like -1 or something?
It's not negative. Oh, because you're thinking about e to what power is 1/2.
So could E
It's negative 0.693, so it is negative. So technically we have a negative there, just we don't have the negative sign there, right?
Okay, I would like it better if there was a negative sign there.
Okay. So what do we want to do now?
Plug in, put it back in.
Okay, so we have y equals 10 times e to the bad stuff. Natural log of 1/2 divided by 24,000 t. Now what are we doing?
Wait.
For one graph.
Okay, so where's the 1 gonna go?
Y.
For the y, because that is the amount that we have, and we are wanting to solve for the time at which that will occur.
Yes.
So what do we do?
Divide by 10.
Okay? So we get 1/10 equals e to
Do that.
all of that stuff. And then
And then do the thing with the E.
I need to take a natural log.
Yes.
And then
Multiply by
24,000,
24.
no, 24,000 over the natural log of 1/2, right? To get rid of both. I mean, you could do it as 2 steps, but it's easier just to do it by the reciprocal of that fraction. So we end up with 24,000 times the natural log of 1/10 divided by the natural log of 1/2.
Equals T. And if this was a non-calculated question,
That's our answer.
that would be our answer. But this is a calculated question.
Yep.
Because I want to know.
Okay. So what do we get?
Who has out their hand getting the calculator? It's probably because it said handy dandy.
Did we get a number?
It's a big number.
It's a big number this time, not a small number.
79,726 years. About
79,000
726
point
274.
e.
It's older than my dad.
Probably so. So about 80,000 years later, we will still have a gram of that stuff left to be
Yes.
radioactive with.
Why are we
Love
doing
that.
a chemical kinetics?
And it'll keep going.
Because
and
what-
never truly goes.
Why do we learn calculus? To be able to do physics, to be able to apply it to
Physics is great.
chemistry, to be able to do all of the higher level science and mathematics stuff, you have to know calculus, okay, and be able to apply it.
STEM.
Yeah, they're all related. That's why we like it.
Unfortunately.
drawing little animals. Is that better? You like animals one?
Yes.
Okay.
Exciting and
Yep.
marvelous. STEM, super terrific, exciting, and marvelous.
Alright,
There.
so
Nine.
right, the rate of change of the number of coyotes in a population is directly proportional to 650 minus nt, where t is the time in years. When t equals 0, the population is 300, and when t equals 2, the population has increased to 500. Find the population when t equals 3. Well, running?
System.
No. Let's set up an equation to start with, yeah? Okay. Now, what does it mean by the rate of change of the number of coyotes? What is that?
Slow
Yeah. Of what?
coyotes over time.
Okay. And what variable are we using to represent coyotes? N. So we have dn divided by dt is directly proportional. Okay, so what did we say that means?
The
K times whatever it tells us it's proportional to. So
Yeah.
in this case it would be 650
minus
minus n. We're just gonna say it's n, okay, for right now. Yes?
yeah.
Should.
Yes.
Because we have to remember in the back of our minds that our n is dependent on t's, okay? But it saves us the trouble of having to write n of t 500 times. Alright, are we okay with that?
Mm-hmm.
Now, in order for us to do what it's asking us to do, we need to have an exponential equation in order to be able to plug into. What does that mean we're probably going to have to do with this?
We can take the integral of it. We can integrate it.
Well, we can't integrate it as it is, but yes, we're going to need to integrate it. Yes. So, we're going to move the stuff with n's to the
the other side.
left, so we
Yes.
would have 1 over 650 minus n dn, and then I'm gonna multiply
That times
by my dt.
yes.
Are we all okay with my steps up till here?
Absolutely.
So then if I want to integrate both sides, the right side is pretty straightforward. We're just gonna end up with kt plus c. What would we have to do for this one?
Natural law.
Yeah, so it's technically gonna be a u sub,
Yes.
but we're just gonna end up with a -1 times dn. Okay, so we just end up with a negative natural log of the absolute value of 650 minus n.
Mm-hmm.
Yes?
Yes.
Back of the room, are we okay up until there? Alright, so now what do I need to solve for?
And
We want to solve for n. Okay, so what would I do first? Huh?
Oh, you're still then?
No. I need an equation before I can do that, so you want to solve for n first.
Okay.
So we're gonna need to exponentiate this, but we can't exponentiate it until it is by itself. So we would get negative kt plus c. C is just a constant, so even if I throw a negative on it, it's still just a constant, so that's alright. Then if we exponentiate both sides, we get the absolute value of 650 minus n equals, remember, so we would get e to the negative kt plus c. But since I have a plus c there, what can we do?
Drop the constant.
Drop it to the front. So we get c e to the negative kt. And again, we can drop that absolute value by a plus or minus, but our c just kind of sucks up that plus or minus. So then we could say add n and subtract ce to the negative kt. And this is our equation.
Yep.
So what do we need to do?
Find C and K.
Okay. What is? Be careful. So what is C in this case?
300.
No, because.
I don't have just our normal C, E, 2D
Oh,
stuff,
you're
right? So that's why I said be careful. So we still want to use that
Three
initial
fifty.
condition. Yes. So we would plug in. What do they give us?
0 and
300,
300, and
yeah.
2 and 500.
So we get 650 minus C. So we get that C is
350.
350.
Yes.
Hit the red.
We're almost there. We can do it. Okay,
Oh, we almost said it feels like a
we are. So then what do we need to do?
Find K.
So we have n equals 650 minus 350, and we're going to use our second piece of information, right? So the 500 equals
650 minus 350 e to negative 2.
Yep.
Okay.
So then we would need to subtract 650, divide by 350,
Mm-hmm.
and we get 3/7.
Wouldn't it be negative? Or no,
Subtract, divide by
negative.
negative, it ends up
Yes.
being positive. Then natural log that both sides.
Mm-hmm.
And K equals the natural log of 3/7. It's going to be negative. Divided by 2.
Sure.
Yay! And last step.
Find the population.
Yeah, so n of 3, I need to plug in all of the things now. So 650 minus 350 e to the
Because K is negative, then wouldn't that make that natural log positive?
positive. Yeah, so we would get positive natural log of 3/7 divided by 2 times 3.
Yes.
Yay!
Jesus.
And then we would plug all of that into our handy dandy calculator. And we
Uh-huh.
get approximately 552 coyotes.
Is that rounded down?
I would have to double check my calculator.